as we call it, it felt like a movie plot. But this was not Hollywood. Last November, just before Thanksgiving, a Falcon 9 carrying NASA's first planetary defense test mission launched from the Vandenberg Space Force Base. And after a 10-month journey, millions of miles, NASA successfully crashed a refrigerator-sized spacecraft into the asteroid Dimorphos, 7 million miles from Earth, and it came in at 14,000 miles an hour, and it was a bullseye. But why would NASA do something like this? Well, if an Earth-threatening asteroid was discovered and we could see it far enough away, this technique could be used to deflect it. And so today, NASA confirms that DART successfully changed the targeted asteroid's trajectory. Now, how do we know that? Well, prior to DART's impact, it took Dimorphos 11 hours and 55 minutes to orbit its larger parent asteroid, Didymos. Since DART's impact, astronomers have been using telescopes on Earth to measure how much that time has changed. And now the team has confirmed that the spacecraft's impact altered Dimorphos' orbit around Didymos by 32 minutes, and therefore successfully moved its trajectory. In other words, DART shortened the 11-hour and 55-minute orbit to 11 hours and 23 minutes, and it moved it in another location. And that has been confirmed by the telescopes. It was expected to be a huge success if it only slowed the orbit by about 10 minutes. But it actually slowed it by 32 minutes. Dr. Lori Glaze and the DART team will explain more about how we confirm that. Now, this is a watershed moment for planetary defense and a watershed moment for humanity. And that's why it was fitting that DART was an international endeavor. Science benefits humanity. This is a unifying mission. And thanks to Italian Space Agency President Giorgio Sacoscia, I thank him for his partnership. All of us have a responsibility to protect our home planet. After all, it's the only one we have. And this mission shows that NASA is trying to be ready for whatever the universe throws at us. I believe that NASA has proven that we are serious as a defender of the planet. I want to thank you, Gina. Back to you.
Thank you, Administrator Nelson. Now we'll hear from the Italian Space Agency President, Giorgio Sacoccia.
Hello, Giorgio Sacoccia here. First of all, let me congratulate Senator Nelson Bill. You and your team made really history with the deviation of the asteroid. I think is something that we can really be proud of as an international endeavor. And I think our planet can feel a bit more safe for the future. From our side, from the Italian Space Agency point of view and the Italian team that supported this mission, it was a unique opportunity to be the reporter of the events, we can call ourselves this way, because our Licia Tube satellite was a spacecraft detached from DART, from the mother spacecraft, 15 days before the impact. And the spacecraft learned on its own how to follow DART in its course towards the asteroids. And about 1 hour, say, before the event, it started an autonomous course to be ready to take pictures and be the witness of the event. LisaCube had on board 2 optical cameras that were supposed to be used to monitor the event, but at the same time to guide the navigation of the spacecraft, which was done taking advantage of the algorithm of artificial intelligence. It was a very small spacecraft, a CubeSat, but extremely intelligent and smart to monitor something so difficult. Just to give an idea, we're talking about monitoring an event while traveling at a relative speed with respect to the asteroid of 6 kilometers per second, about 4 miles per second. So LisaCube had to watch the event and then do a flyby of the 2 asteroids and turn to continue monitoring what was happening. It was really, really something challenging, but when after the impact took place, you can see we have prepared 2 videos. The first one shows the last seconds before the impact, and you can see the change, basically a little change in the little dot, which is Dimorphos, showing the ejection of the material. But of course, a second video we prepared shows what actually happened during this approaching of Dimorphos, the flyby and the turning of the satellite, and getting far away. So what you can see in the second video is actually the approaching from 700 kilometers of distance, then the flybys were went very close, up to 59 kilometers from Dimorphos, and then you can see while we're getting more far away of about 300 kilometers. So I believe what you're seeing here is really, really fantastic. I remember the night when from the control center at the Argotech premises, our prime contractor, we started looking at those images. We couldn't believe our eyes that actually we made it. And we made it thanks to this fantastic collaboration with colleagues from NASA, and we are really, really proud of that.
Thank you, Mr. Sakacha. We're so pleased that you were able to join us on the line, and we understand you'll stay on for questions. Next, we'll have Ms. Lori Glaze.
Great. Thank you so much, Gina. Let's all just kind of take a moment to soak this in. We're all here this afternoon because for the first time ever, humanity has changed the orbit of a planetary body, of a planetary object. First time ever. You've heard that the team has measured that the orbital period of Dimorphos has changed from a period of 11 hours and 55 minutes to a period of 11 hours and 23 minutes. That's a change of 32 minutes with a precision of plus or minus 2 minutes. And Nancy's going to talk a lot more about how we know that and why we're confident in that number. But I want to take a moment here just to give my sincere thanks to the entire team. This is a big effort. The team at Johns Hopkins Applied Physics Laboratory, to the Italian Space Agency, and in all of the collaborating partners that have contributed to achieving this remarkable measurement and this achievement. So we've been watching this mission, and as you heard, the the minimum requirement for changing the orbital period was really only 73 seconds. But based on models, the team had been looking at a broad range of parameters for the potential physical properties of Dimorphos. And from those models, had estimated we would make a change of between a few minutes and several tens of minutes. And so what you've seen here is that that result of 32-minute change is consistent with the estimates that were made beforehand, but clearly at the upper end of that range, which is really fascinating. You'll hear more from Tom about what else we can learn from these data going forward. But it's just been so cool. The whole world has been watching this since DART impacted Dimorphos 2 weeks ago on September 26th. And if I could pull up my first image, please. We've had observations from around the world, ground-based telescopes and even a couple space-based telescopes. I just want to share a couple of them with you here. This image here was taken by the SOAR telescope in southern Chile. And let me just describe a little bit of what you're seeing. You just saw images from the Lucia cube going head on, looking at a cone of ejecta coming off of Dimorphos. Well, here now you're looking at an image, that same kind of view, but from side on. So you're seeing that ejecta cone kind of facing out to the left. And you can see one arm of that cone pointing down to about 8 o'clock, and then the top arm of that cone pointing up to about noon. And so we can see that cone here from the ground. You also see this really bright streak going off towards about 2 o'clock. And it looks kind of like the tail of a comet. And that's because what we're seeing there is this fine-grained particles that were ejected from the asteroid being driven away from the asteroid by solar radiation pressure, very much akin to a comet. So very cool observations here. This image was actually taken 2 days after the impact. And if we go on to the next image, please. We're continuing to take images. This is the latest and greatest, hot off the press, Hubble Space Telescope image that was collected on Saturday. And what you can see here is that ejection cone, again, we're looking side on, that bottom arm of the cone is still pointing down to about 8 o'clock, but the top part of that ejection cone has kind of gotten pressed back, again, with that solar radiation pressure. And you can also see that comet-like tail has now kind of split into two as it gets away from the asteroid. This is so fresh and such a new image that the scientists are still working on interpretation of that kind of double bifurcated tail. It's about 10,000 kilometers across here in this image. Really fascinating stuff. The learning is going to continue for a long time to come. And so with that, I'm going to pass it over to Nancy to talk a little bit more about the results.
Well, thank you so much. It's really a pleasure to be here today. And I really just need to start by also just acknowledging what a team effort it has been in order to get to this moment. From the team who built the spacecraft, from the team who so successfully led that spacecraft to guide itself to that spectacular collision, to really the team that's been working ever since that collision 2 weeks ago to understand what happened to Dimorphos. Been collaborative around the world in order to get to this result today. And I'm just really happy to be here as a representative of that large international team to share that result and to dig into this data a little bit. So digging into the data, one thing I want to stress up here at front is that there are two different types of observational data sets, both completely independent, that were used from data collected here on the Earth in order to arrive at this result of 32 minutes for the orbital period change. And they're both completely consistent and supporting this result that we've heard of this 32-minute orbital period change. If I could have the first animation, please. The first data set and method used by the DART team uses optical telescopes here on the Earth.
Mic check, mic check. I got booted out. Mic check, mic check.
Telescopes, you can actually distinctly get signal from both Dimorphos and Didymos directly. And this is an important distinction. So the Goldstone Observatory in particular has been tracking the position of Dimorphos regularly every night for the last 2 weeks, roughly. And from those, they have also been tracking that this is an 11-hour and 23-minute period currently for Dimorphos around Didymos, with a 32-minute orbital period change. If I can have the last graphic for me, please,
It's
here.
the numbers.
Additionally, on October 4th and October 9th, these radar facilities were able to get some direct images of the Didymos and Dimorphos system. Here you see Didymos, but also directly in the image, you can also get signal from Dimorphos. And so we're directly imaging both of these asteroids and getting their positions relative to each other. And the position of Dimorphos is consistent with 11 hours and 23 minutes for its orbital period, and it is not consistent with being what the orbital period was prior to the DART impact, which was 11 hours and 55 minutes. And so this is just another example of these two independent methods all giving you this same answer. So this is a very exciting and promising result for planetary defense to have this orbital period change of 32 minutes. It's within the range of the models that have been studied, but it's also definitely indicating that you're getting an enhanced deflection due to the amount of ejecta, that rocky material that's being thrown off when the DART's collision happened. I think it's also, though, important to put this into perspective of a kinetic impactor technique if you wanted to use this in the future, potentially to deflect an asteroid. This is a 4% change in the orbital period of Dimorphos around Didymos. And it just gave it a small nudge. But if you wanted to do this in the future, potentially, it could potentially work, but you'd want to do it years in advance. Warning time is really key here in order to enable this sort of asteroid deflection to potentially be used in the future and is part of a much larger planetary defense strategy. So I'll just end by saying that it's exciting that we've taken this first step to develop and now to successfully demonstrate asteroid deflection in space with the DART mission. The DART team is very happy to be sharing this initial result, even though there's still a lot of work to do. And I'll pass it over to you, Tom.
Thanks, Nancy. It's so wonderful to see this result for the period change of the binary asteroid. We've been imagining this for years, and have it finally be real is really quite a thrill. But as Nancy said, this is really just the start. It really is just the beginning of the analysis of this tremendously rich data set that we're going to get from the DART mission. In addition to the observations, which are ongoing and will continue for some months, we also have a lot of work ahead of us in order to really understand what happened. We're going to be analyzing the images from the DART spacecraft and from LiCiCube to get shape models. We need to get a never before in-hand shape model for Dimorphos. We didn't know what it was going to look like before we got there, and now we do. We'll also have a refined new shape model for Didymos. There might be some revisions, refinements to the average density of the system, and that plus the shape model giving us the volume of the asteroids will give us the first real determination of the mass of Dimorphos, the asteroid that we actually impacted. That's going to be tremendously important going forward. There's also going to be intense work done on the beautiful ejecta plume that was imaged by LiCiCube and that is seen every night by ground-based telescopes. What direction did the material go in? What were the sizes of the particles? How much was there? We might be able to get an estimate of the amount of mass in the ejecta plume and how fast it was moving. And that also is very important to understand what happened. The team's going to be working to understand
water,
in detail
QUA.
the new orbit, the new 11-hour and 23-minute orbit. How out of circular is it? How elliptical is it? Is there a little bit of a wobble induced? Did we induce a wobble in Dimorphos itself as a result of the impact? And the physics simulators on the team will be simulating the impact again. Even though they've already done it, they're going to do it some more in order to match up the predictions of the simulations with the actual observed
In
property.
order to match up the predictions of the prophecies from King James Version to make sure that it truly matches.
Opportunity where I've gone from there to I've gone to
Wait, ain't
flight.
that AI right there? That's AI right there. I saw them do an interview with him, but this right here is AI. That's AI. That's hold up.
Accessories, so seeing the different umbiblicals, how they work, how they secure the rocket to the mobile launcher, to seeing different tests that they're performing on the instrumentation.
Now I got booted out of that live presentation. Hold up. I want to go back and try to click on it again. See if they're still live, still talking that bull crap. Let's see. Hold up.
Yet to come.
There we
I
go.
want to finish off with one more image. And this is
Okay, I was saying they definitely set up the set for his head to be in between the H and the D. And you know what qua mean?
spectacular image taken from LichiQ and enhanced by the DART team to bring out fine structures. The rectangles that you're seeing are not real.
What is that
It's just that in
symbol?
each successive rectangle, the contrast has been boosted by another factor of 2 in order to bring out that faint structure. And this is just a visually stunning image. And every little wiggle in those streamers, every little blob,
Every little blob in the top of the capstone of the pyramid. That's a pyramid now. Nope. Or we could say the hall of mirrors. You could use, there's so many different translations of that right there. But since they're live, I'm gonna let it continue. I'm gonna actually come back later so I can spend more time playing and enjoying the mission to retrieve the fake globe off of the space. What was that orbit? The pre-orbit earlier? Yeah, me and my grandchildren, we playing. We on a mission, a space mission. But that 11:55 transition, meaning that the 10:11 portal has been um, done away with. It could be some more in depth, but I have to because it was coming to me as I was listening to it in the kitchen making the chicken salad sandwich. Chicken salad sandwich. For the family's lunch. So I didn't dart in or jot any information down, but this initiation of the rape of the solar system that they did, um, I will update and I'm gonna go ahead and let this play because I see exactly, I can see what it is. I can see it. I can see it. I can see
every
it.
little particle that you
Oh, and the countdown is still on. I'm just leaving information for y'all because if I get left behind in this mess that they're ready to start, they finishing their niche. This is the finalization. Unless the extension of the 32, they need a. Did they say 23 or 32? I'm gonna go back and listen to that because 32 minutes back would take you exactly, or my life back 32 years to the beginning. 32 years to the initiation of everything that happened with my son. 32 years to be exact. Now, remember, said that in the blood work and all the different, like CRISPR and all these different entities that have my DNA, and I have it on record and, screenshot stuff that I've been doing over the years. I ran across something under the Royal Institute where my bloodline goes, where it said my blood is no longer what you call it, this blood type is no longer, I screenshot it. So I don't know. I don't know. Yeah, I don't know. Mm, who knows? Who knows? They lying. They lying about something. This is this. I don't. NASA, NASA. I can see right through you, NASA.
See is a clue to something. It's a clue to something that happens on the surface of an asteroid when
They can't be direct. It got to be clues. Let me stop because I'm gonna go over this later. I'm gonna go
an
over it
object impacts it. And if you're looking at this image and a dozen new questions are popping into your head that you would have never have thought to ask before seeing this, well, that's just one of the hallmarks
Oh,
of great science.
soon,
It
Jimmy.
opens up new questions that we would have never
Peace,
thought to
peace.
ask.
Oh, soon.
But in addition
Oh,
to the
soon,
science
the dark
value of
side.
this image, I really love it because it is artistic, it is poetic. And even though those rectangles aren't real, they're suggestive of windows of understanding. We're opening new windows of understanding, looking deeper and deeper and deeper to gain a better understanding of not just how to defend our planet against this natural hazard of asteroid impact, but also to understand how our solar system works and how we got to be where we are now. So with that, I'll give it back to you, Gina.
Thank you so much for that update. We are now ready for our questions and answer time. We do have some reporters on the line, but if there are any questions from reporters in the audience, please grab a microphone and okay, great. And make sure you state your name and media affiliation.
Thank you. We will now begin the question and answer session. If you would like to ask a question, please press *1, unmute to your phone, and record your name. Your name is required to introduce your question as well as your affiliation. If you need to withdraw your question, press *2. Again, to ask a question, please press *1. It will take a few moments for the questions to come through. Thank you.
Thanks, operator, and I will call on you when I'm ready to ask for questions in the room or on the line. Thank you.
Yeah, hi, it's Joel Achenbach with the Washington Post. This is all fascinating. Congratulations. Basic question, is this a plausible, deployable type of technology for deflecting an asteroid based on the results of this test? And also, can you just explain a little bit about why was the change in the orbital period at the high end of estimates? Just what mechanically was happening there? I know you referenced the ejecta and the recoil, but I mean, can you explain the Newtonian mechanics of that?
I think you should take the first part, and then I'm happy to chime in after.
Yeah. So on the first question about is this a viable technique for the future, I think that the DART mission has demonstrated that we are capable of deflecting an asteroid, even a potentially hazardous asteroid of this size, using a kinetic impactor technique. As Nancy said earlier, one of the key pieces to being successful with implementing a technique like this is early detection. The more time we have for that little nudge in the change in that orbital period to really make a change, the better off we are. The key point of this type of technique, of course, is to just give that little nudge such that the asteroid crosses over Earth's path either just before we get there or just after we've gone by, so that we don't actually end up in the same place at the same time. So I think this has been an incredibly successful demonstration of the kinetic impactor. And so
that interference that's coming through, I don't know what that is. It almost sounds like my conch shell blow that I've been doing lately, but that, I can't find out where it's coming from. So I hope the sound isn't blocking out, what they're saying here.
Hopefully we've got that tool in our toolkit now. I'll pass it over to Nancy for the other half.
Yeah, thanks. So period change of 32 minutes is spectacular and exciting. And
see the set, the G, the GO, the G, and You see?
And what the DART team is working on right now to understand. So the DART investigation team has over 200 members that are on 28 different countries. We've been meeting daily and having really intriguing discussions that are fascinating, and we have to cut off time just so everybody can get some sleep or get back to the
What is that G symbol upside down again? And it's not E, and we know it's um, uh, indicative to the power symbol sign, but in is it Roman letters or Greek or something? When it's upside down, I know in Nuwapu there's also a symbol. But what is it for them? What is the G, and why is it so important for them to flash it like this behind um, the gesture, the clown, her face?
telescopes and do everything that's been going. So this is active, what the team is actively doing right now. We're really happy to be sharing this first initial result. It is on the high side of, some of the models that were run initially, so we feel confident saying that the ejecta is contributing in a substantial way. But yeah, come back in a little bit, and we'll be happy to share the results of those models that the team is working on about what specifically is causing that and what that means, not just for what happened to Dimorphos, of course, but what this means for potentially applying this technique to other asteroids in the future, if the need should arise.
Thank you. Do we have any other questions in the room? Yes.
Oh, I remember her with Neil deGrasse. I remember her watching her and a couple of their oh, she changed her hair, let her hair grow or something. Okay.
Hi, Jenna Biter, Coffee or Die magazine.
When I used to watch the string theory, quantum physics shows. That's what I call them, shows. I don't want to say conference, whatever.
First of all, congratulations. What an amazing milestone. So the administrator mentioned that in addition to the orbital period changing, that Dimorphos was moved a little bit. Can you go into that and how it how the DART impact affected the binary system overall?
So along with changing it, because it still is a double asteroid system, Dimorphos just now orbits ever so slightly closer to Didymos than it used to previously. Again, this is a few percent change in that actual distance, and it's just slightly closer. It's sort of tens of meters closer. But this, again, is one of the specifics that's being worked out, as Tom alluded to, with all of this ongoing work to really understand that. But because we came in and the DART spacecraft hit it sort of head on, it just makes it be bound even more tightly to Didymos than it was before, which is why this double asteroid system was such an ideal target to do this first test for planetary defense. Tom, if you wanted to add to that, please.
Nope, that was exactly what I was going to say. Perfect.
Thank you. We have one more in the room, and then we'll take questions on the line.
Hi, this is Assam Ahmed here from AFP. Yeah, just in terms of the better than expected result, in terms of there being a greater plume of ejecta imparting more momentum, is that result generalizable now, do you think? Does that mean that, that you'll factor that into your models moving forward and you think more asteroids are generally like this that are of concern? And secondly, what would be your next, what would you like to see as the next move in terms of planetary defense testing? Thank you.
I can start on some of that.
You see the psychology that they're trying to use, even in the way that the questionnaires, that's what I call them, the questionnaires, or the questioners, the ones posing questions that was already set up, just in the way that they're dressed, like how his hoodie is hanging off his shoulder, like for something this momentous or historical for the world, so they claim. Both parties, the first young lady or whatever she is, and the second gentleman or whatever he is, seem to be dressed inappropriately for such a monumentous historical world changing space binary uh, success, I guess. If that one- It's,
Of course, this is one test, and it's one test done on one
as to
asteroid.
say, you know, the average Joe, you know, this is, you know, for everybody.
And of course, what we're learning.
And all three of the hosts, you know, him with the hard qua HD behind his head, her with the GG go gaga and all that behind her head. They all look like aliens to me.
Learning every time we send a mission to another asteroid is we learn that each asteroid has a different part of the story of our solar system's past to tell. Asteroids are not all the same. The asteroids in the main belt and in near Earth space have very different histories. Most of them
Didn't
have
I
been
say I was gonna let them talk? Okay, I'm gonna let them talk.
shattered and reaccumulated many times, but we know that there are objects of different types. We know that there are objects that are rubble piles, like Bennu, for example. We know that there are objects with diverse surfaces. So we should not be too eager to say one test on one asteroid tells us exactly how every other asteroid would behave in a similar situation. But what we can do is use this test as an anchor point for our physics calculations and our simulations that tell us how different kinds of impacts in different situations should behave. We anchor it with this bit of ground truth, and then that tells us how better to extrapolate to other situations.
And if I'll just add one thing before I'll pass over to you for the next steps. I think one of the things that's really interesting here too is that Dimorphos is a size asteroid that is a priority for planetary defense, this sort of 160 meter sort of object. And it's the first time we've been to an object that size and seen how it reacts too. So I think that's another important point to, you know, that Tom was talking about, to anchor our knowledge in, and that this is a size that's directly relevant to planetary defense that had not been visited before.
Yeah, so I'll take the question about, you know, what would be next. And I think there's two things that are really important here. And you heard Tom say that, you know, this was one test on one asteroid. And that in this case, it appears that that particular asteroid may be this kind of loose collection of debris out of material, but not all asteroids are like that. Some may be a solid rock as opposed to a collection of smaller rocks held together. And the way they react is going to depend on whether they are solid or whether they're these collection of rubble. So one of the key things that will be important that we should be thinking about going into the future is how can we respond quickly if we identify a potentially hazardous asteroid that's out there, maybe decades away, but be able to send a mission out to look at it and get more information on how big is it, and is it a collection of rock, or is it a solid body? So that's one thing that's really important. But actually what I just said there is you got to know they're coming. And so the very next thing that we really need to do, of course, is to complete our inventory of these objects in the solar system that are potentially dangerous to Earth. Again, from this size category of about 140 meters and larger, our next goal is to try and make sure we can identify those and characterize those. And we actually have a mission in the pipeline, the Near Earth Object Surveyor, that's intended to do that.
Thanks so much. Now we'll go to questions from the media on the line. I just want to confirm that Mr. Giorgio Sacaccia is still on the line as well?
Yes, I'm here.
Awesome. Thank you. All right. Operator, can we please have our first question from media on the line?
Yes, Ms. Marcia Dunn, your line is open, and please state your affiliation.
Yes, hi, Marcia Dunn, Associated Press. Thank you for this. When did you find out, what day, that you had achieved this 32-minute orbital slim down? I'm just wondering how many days of observations it took, and I didn't know if it came over the weekend or late last week. And what if Nancy and Tom could both say what their reactions were upon first learning of this 32-minute miss?
So I'll go first. We had been saying the telescopes would need time in order to do this measurement, and indeed they did. But I think this is really credit to the enthusiastic international team that we have that got on this so quickly, both from the optical telescopes and from the radar observations, multiple groups around the world that these data started pouring in. Like I said, as a team, we were holding these daily meetings and also sort of communicating throughout outside of those. And I think it's that enthusiasm and that teamwork that, you know, we share ideas on there. And so it's hard to pinpoint exactly when maybe the team, you know, had complete confidence in this result. But we have been tracking it for these last 2 weeks and are completely confident now.
Yeah, maybe I'll speak to the other half of the question. So as Lori said earlier, the team before impact has been spending years trying to understand the range of possible outcomes of this experiment, not knowing what the target was going to be. And so they did simulations on solid rocks and broken rocks and fractured rocks and piles of rocks and rubble piles and piles of gravel. And there was this immense range. And one of the things we did understand from those simulations is that we expected a solid rock to be less responsive than a pile of gravel. A loosely bound rubble pile would have a big response. So I won't speak for anybody on the team other than myself. But the last few minutes before impact on the 26th were quite dramatic. And when I saw Dimorphos come into view, and when I saw there was not a single crater on it, and there were a lot of what appeared to be loose rocks, and this was a totally non-scientific by eye measurement, I looked at it and I said, this is not going to be 73 seconds. And it wasn't.
Excellent. Thank you. Operator, do we have any other questions on the line?
Yes. Jeff Faust, your line is open, and please state your media affiliation.
Good afternoon, Jeff Faust of Space News. I know one of the factors you talked about leading up to the impact was measuring beta, the efficiency of the impact on the asteroid. Do you have like a range of beta values that are consistent with this 32-minute orbital change that you've seen? Thanks.
I'll start and Nancy can chime in. Nancy knows beta is my favorite subject. So we're going to be working really hard to get a beta. It is, as we said, it seems virtually certain that the ejecta were a significant contributor to the period change, and so we know beta is not equal to 1 because that would have been no ejecta. But there are a lot of ingredients that go into a definitive beta determination, so that work is ongoing. Nancy, do you want to add anything to that?
No, I'm just happy that people are asking these questions and so interested, and that'll motivate the team even more to get to work and come back at you with an answer once we've run some more of these models.
I think they're working now.
Okay, I understand we have several questions on the line, but I wanted to check in the room to see if we had any additional questions. Okay, operator, let's have our next media question.
Thank you. Sarah, your line is open. Please state your affiliation.
Hi, this is Sarah Schultz for the New York Times. I was hoping you could say a little bit more about what the continuing follow-up observation plan looks like and a little more about what you hope to learn from that campaign. Thank you.
So the observational campaign for the DART team will continue. The timing of DART's impact into Dimorphos was actually chosen when the distance between Earth and this asteroid system is at a relative minimum. And so observations can actually continue into early 2023. So right now we have this orbital period change of 32 minutes with an uncertainty of plus or minus 2 minutes. Additional observations will help to better refine that answer. In addition, the tail is spectacular, this amount of ejecta that you're seeing, and it's continually evolving. And so the observations are going on in order to fully track and watch that evolution of the ejecta. And so these are the two main things that the observations will continue to be doing for the weeks and months to come.
Excellent, thank you. Can we have our next question from a media on the line?
Daniel, your line is open. Please state your affiliation.
Hi, this is for Adrian Uruguay from Uruguay, Spanish audience. Thank you and congratulations for all the NASA team. My question is, what is the largest mass that we could impact on an asteroid, and what technological limitations do we have to do an aviation? The other one is the change permanent, the orbit change we made to Dimorphos? Thank you.
Can we ask to have you repeat the question, please? There was a little bit of feedback in the room. Can you repeat the questions again, please?
What is the largest mass that we could impact on an asteroid, and what are the technological limitations that we have? And the other one, the second question, is if the change of the Dimorphos orbit is permanent or not.
Understand it's the largest mass that we can impact.
Well, I heard the end of the question. It is a permanent change, although we have done more to the system than simply change the orbit. We may have left Dimorphos wobbling a bit. So over time, there may be some interaction between the wobble and the orbit, and things will adjust, but it's certainly never going to go back to the old 11-hour, 55-minute orbit. So for intents and purposes, it's permanent.
And I think the other part of your question had to do with the mass and how large of a mass. And I think there's a lot of factors in play there in just how large or how far this technique could go.
Yeah, and I think there's some studies out there, and the National Academies of Science decadal survey had planetary defense included for the first time, and it really is related to the mass of the asteroid, but then the x-axis is always warning time. It's always how much time you have to deal with this. So if you find the asteroids ahead of time, it's very reliable that NASA and other space agencies can have decades of warning time, can track these things reliably for 100+ years. And so that's really lets you deal with larger objects if you have that warning time. So I think I just want to stress, this is spectacular that we've taken this first step for a kinetic impact or deflection to potentially be used in the future if we need to. But we really need to also have that warning time for a technique like this to be effective.
Excellent, thank you. I understand we have several questions on the line, but I wanted to check back in the room to see if we had any other questions from media in the room. Sure.
Hi, Laurie, you mentioned the NEO surveyor mission, and I had a question about that. I had read, and correct me if I'm wrong, that we know of about 40% of the asteroids that can cause regional devastation. How was that statistic? How did we come up with that statistic?
I'll give you my stab at it, and then Tom can correct me. How's that? By looking at the population of asteroids that are out there, we have an estimate of how many there are. There's a size distribution. We can see the various sizes of the different asteroids that are in these near Earth orbits. And so we have a prediction and an estimate of how many we should see at each of the various size ranges. So for those objects that are a kilometer or larger, the really big ones, we've actually identified, I believe it's like 99% of those. They've been identified. We don't believe there's that many more of them out there that we haven't found. But when you get down into this range of about the 140 meters and larger, as I said, or you noted, right, that's a size that really could cause regional devastation. So that while it wouldn't wipe out the whole planet, they're certainly of incredible concern. And of those, we are continuing to make observations from the Earth base, and we also have the NEOWISE spacecraft that's making some observations. But through those, we believe we've, at this point, only identified about 40% of that size, that population, that's larger than 140 meters.
Yeah, I can add a little bit to that about how we know this. So we've had asteroid surveys, asteroid searches going on for a long time. And so we've got a pretty good idea of, excuse me, what are the range of asteroid sizes, and also what are the distribution of orbits in the solar system. And we also know for each one of those surveys, what are their capabilities, right? What are they able to see at what distances? So for every observatory, you can figure out how efficiently they're able to detect an asteroid of this size on this kind of an orbit and so on. And so knowing from that how incomplete the discoveries are, you can work backwards and figure out what has not been discovered yet.
Great. Any other questions in the room? Okay, operator, can we have a couple more questions on the line?
Gina, your line is open. Please state your affiliation.
Gina Sinceri, ABC News. How important was this that this be an international cooperative mission? What did that add to it?
I'll take a first stab at that one. I think that's incredibly important. As you can imagine, of course, planetary defense is not just a problem for the United States, nor is it a problem just for the Italians that cooperated on this mission. But this is a planet-wide issue that if there were an asteroid that were a threat to Earth, we should all be concerned, and we all need to be working together to identify the asteroids, which we do with our ground-based programs, the entire world with telescopes around the world looking for these objects and working together when one is identified to follow up with observations, to characterize them so that we can put them into a database and keep track of them over time. And so working together as an international community, I think this is one of the most important things we can do for planetary defense.
If you like, Giorgio Sarcocha here, I can add something to.
Please do, Giorgio.
I can only confirm, of course, that protecting our planet is from space and from ground to threats that come from space is by definition something that we have to do together. And for this reason that the only way to grow is to cooperate at the international level. It has been mentioned ground-based observatories that would monitor our environment. For example, here from Italy, we have developed ad hoc telescopes that works as the fly of an eye, eyes of a fly, so composite mirror and lenses telescope to monitor wide areas of the sky to detect as soon as possible threats. In addition, as you have just seen, we were very, very happy to cooperate with NASA with the Leisure Cube satellites, and there will be many other initiatives that will be dedicated at the international level to protect our planet. By the way, we took 720 and more pictures in those 10 minutes of observation, so I'm sure that scientists will be working on those pictures for a long time to get the best out of what we have done together with NASA.
I have no doubt about that, Giorgio. Fantastic data set. Can I also add that just from an international perspective, that the next mission to fly to the Didymos system is going to be the Hera mission, which Tom mentioned, that is being planned by the European Space Agency. Again, a multinational endeavor to again go back to this system and get a chance to look at it again a little later on. So again, I think the international participation, this is a real opportunity for the entire world to participate.
Excellent. We'll take another question on the line.
Marvin, your line is open. Please state your affiliation.
Hi, good afternoon. My name is Marvin Marshall from the Nighttime News Space Report here on Twitch.tv. This question is for whoever wants to answer this. With the data that we received from this mission, how does this scale up, and to what size? Would this mission give NASA now the confidence to send, a whole colony or swarm of these darts up there? And are we gonna have any on standby? We appreciate all your hard work and congratulations again on a successful mission.
I'll start it and pass it to you. So we have a physics understanding of how impacts should scale with size of target and size of impactor and velocity of impactor. If we are ever in a situation where we have to actually deflect an asteroid, we'll want to look at the situation very carefully, because any such event would be very situational. It would depend on the orbit of the dangerous asteroid, the nature of the asteroid. We would want to find out as much as we can about it, the accessible trajectories, how could we get there, how soon could we get there. All of these things play in before you can even begin talking about, well, should we use one large impactor or several smaller impactors? Is a kinetic impactor really even the best choice at all? Among the things that you would want to think about is if it's a relatively small object, but you have to make a large deflection, you might not want to do this with a single impactor because you might accidentally break it, something we don't want to do. Breaking an asteroid is not really the best way to defend yourself from it, because then instead of having one large object heading for you, you have a lot of little objects heading for you, and that's not better. So how to deal with a single situation is going to be situational. Now, how do you turn that into a decision of what kind of ready-to-go capability you want to have? That's more than a science question, more than an engineering question. It's really a policy question and governmental question. So I'm going to pass to Lori for that one.
Well, I'm actually going to go back to Nancy's statement a little while ago, that more important than which asteroids can we defend ourselves from with this technique is we need to know how, when. We need to find them and we need to identify them. We need to characterize them. As she said, time is the single most important factor in being able to implement any technique for defense.
Excellent. Thank you. Do we have any other questions on the line?
No questions. I'm going to pass to Lori for that one.
Well, I'm actually going to go back to Nancy's statement a little while ago, that more important than which asteroids can we defend ourselves from with this technique.
Steve, your line is open. Please
we need to know when. We need to find them and we need to identify them. We need to characterize.
Hi, my name is Steve Gorman, Reuters.
The single most important factor in being able to implement any technique for defense.
Hello?
Excellent. Thank
yes,
you.
your line is open.
Yeah, my name is Steve Gorman. I'm with Reuters, and I wanted to know what combinations of telescopes, if I could run through, so which combination of telescopes, ground-based telescopes and space-based telescopes, if they were also involved, were involved in confirming the results of the DART test.
So the telescopes that have been used so far by the DART team in order to get this result are Las Campanas Observatory in Chile, the Las Cumbres Observatory Global Telescope Networks in both Chile and in South Africa, and the Danish telescope in Chile, as well as the two planetary radar facilities of Goldstone Observatory in California and the Green Bank Observatory in West Virginia.
I will definitely come back and do coverage on this later on. So many things are downloaded as they are speaking, uploaded, downloaded, inloaded, whatever. I'm not gonna rack my brain or anything, because it just sounds like a bunch of bull crap. Since they're covering the truth, since they're lying. But I got some stuff I may point out. And then if I get left behind, then I have more detailed work to do. But I don't think I'm getting left behind. Oh, soon, yum, 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 yum. Oh, soon, yum, yum. Oh, soon, yum. Thank you. Appreciate your presence. And I will be back later. The grands are calling. Greater light.